Hi everyone, my name is Erasmo'22 and in this video I'll be introducing my doctoral project entitled Beyond Accuracy Perspectives on Graph Neural Network-Based Models for Behavioral User Profiling. The main goal of user profiling is to infer an individual's interest or behavior from generated data to create an efficient user representation, referred to as user model, by either analyzing explicit data from surveys or focusing on implicit individual sections and interactions, namely behavioral user profiling. A natural way to model these behaviors is through graphs, where edges describe the interactions between users represented by nodes. In this light, graph neural networks constitute the perfect class of methods to deal with graph data, and recently their effectiveness has been proved in several domains. While existing GNN-based user profiling approaches evaluate their effectiveness as a classification task, I aim to look beyond these usual accuracy-based approaches and simultaneously consider the perspectives of fairness, explainability, and privacy. In particular, the doctoral goal I set is to leverage GNN models to produce fair and privacy-preserving user representations, having the ability to provide tailored explanations to the end users through an adaptive and personalized user interface. To achieve the intended goal, the principal outcome of my thesis is the implementation of a GNN-based behavioral user profiling framework whose architecture is displayed in this slide. The contributions of this doctoral research are shaped around the three outlined beyond accuracy challenges and defined by the following research questions, one for each perspective. The first one is about privacy and how to guarantee personal data protection on a graph data structure. The second one is about fairness and how to build fair user representations from GNN-based user profiling models. The third one relates to explainability and how to personalize user interfaces to adapt the explanation to the needs of different end users. In the first 2 years of my doctoral project, I published the following contributions. For privacy perspective, I developed a first pseudonymization approach for privacy-preserving recommendations on academic graph data. Regarding the investigation of adaptive and personalized user interfaces, I carried out a user study among researchers belonging to various research fields to evaluate two different explainable interfaces for a graph-based recommender, and we also organized the first workshop on adaptive and personalized user interface at UMAP'22. For fairness and explainability perspectives together, I designed and implemented a system with the scope to show how the use of these techniques can lead to the growth of a domain expert's trust and reliance on AI system, also proposing a novel scale to evaluate XAI systems. Here you can find my contacts, and thanks for your attention.